Hi everyone, welcome to Java Techie. So in our previous video, we talked about what is Kafka Stream and why we need it, right? That's the foundation. And if you have not watched it yet, pause this one for a moment, check that out, and then come back to this video. Trust me, it will make a lot more sense. Now in this video, we are going to get our hands dirty by building a real-time Kafka Streams application step by step. By the end of this video, you will have a solid understanding of Kafka Streams basic flow and how it actually works in action. Okay, alright. So without any further delay, let's get started. Alright, before we jump into the coding part, let's do a quick recap of how the Kafka Stream flow actually works. Once your producer application sends event to the topic, Kafka Streams take over. Now what it does, your Kafka Stream subscribe to the topic and read the incoming data or events, then it process or aggregate or enrich the data in real time, and finally it write the transformed data back to the another topic or the same destination topic. Super simple, right? Just three steps: read, process, and write. Trust me, once you understand this high level flow, Kafka Streams will feel super easy for you. Okay, now let's focus on today's use case, what we are going to develop. Imagine you are working on a banking application and you are being assigned to design a fraud detection system. Your application is continuously receiving a stream of transaction events, and your job is very simple. You need to filter out those transactions which exceed some threshold. For example, let's say 10,000. Then you need to figure out those transactions who exceed 10,000, then mark it as a suspicious transaction or trigger an alert. This is the simple task you need to do. Now the question here, how do we design this? It's actually pretty simple. Let me walk you through how we can build this flow using Kafka Stream approach. Okay, let's say your producer application is sending a continuous stream of transaction event to a Kafka topic called transactions. Now our Kafka Stream application comes into the picture. What it does, it reads those transaction events from the transaction topic, then it filter out any transaction where the amount is greater than 10,000, and finally it write those filtered suspicious transaction to another topic called fraud alert. Now you could have other consumer application like notification service or account locking service which will listen to this fraud alert topic and do the necessary action. Simple, right? Just a clean and easy use case to start with Kafka Stream. So let's begin with the basic fraud detection flow, and in the upcoming videos we'll extend it to handle more real-time complex scenarios. Okay, alright, then let's see it in action. So to save our time, already I created a simple application where it will just publish the transaction event to the topic, and as part of the dependency I have added Spring Web, Lombok dependency, then I have added Spring for Apache Kafka and Spring for Apache Kafka Streams. Okay, so basically you need this Spring for Apache Kafka dependency only if you are writing the producer and consumer using Kafka. Okay, but if you want to play with Kafka Stream, this is not required. But as per our use case, we need a producer application who will publish bunch of transaction events to this particular transaction topic. Then we have this Kafka Stream application who will process that record. Okay, so the first part already I designed where producer publish the event to the topic using Spring Boot. So I don't want to repeat this example since we have done multiple Spring Boot Kafka example. So I hope you already aware about it. If not, I will share the Kafka playlist link. You can check that out. Now let's open IntelliJ IDEA. You can see already I created a template. Now if you check the pom.xml, we are using latest Spring Boot version and we are using JDK 21. Going forward in whole series, we'll use this JDK 21. Then as part of the dependency, we have added web, Kafka Stream, Spring Kafka. Then I also added the Swagger. Okay. Then we have Lombok dependency. That's it. Now what I did here, I have created a Kafka config where I have write a bean to create a transactions topic. Okay. Now I also define a transaction controller. What it does, it just have a simple endpoint to publish couple of transaction object or transaction object string to the Kafka topic. Okay. Now if you see here, I have created a loop of 10 object and transaction ID will be generated dynamically and amount will be generated within 8,000 to 11,000, and this is what the object I am building. I am converting them to the string, then I am sending to the Kafka topic called transactions. Okay, that is the simple logic producer application I have designed. And if you see the application.yml, I have defined the Kafka producer configuration where I have defined just the bootstrap server and the key serializer and value serializer. For this initial demo, I am using key serializer and value serializer as a string serializer. Okay, that is the simple producer application we have designed. Now, what is our next task? If you understand the flow, our next task, once the event reaches to this transactions topic, then we want to use the Kafka Stream app to read it, process it and write it. Okay, so for that, what you need to do, first you need to define the Kafka Stream configuration. So the configuration is very minimal. Now what you need to do, you need to define stream, then you can define the application ID, give some meaningful name, fraud detection streams, you can give any name. Then the next part, you need to define the properties for serializer and deserializer. Okay, so you can say default dot key dot, okay, default dot key SERDE, which means serializer and deserializer. Now what is that? That is, we are going to use the string here. So just define org.apache Kafka common serialization SERDES and string serialization. Okay, so for this demo we are using string. In upcoming class I will explain how you can use your custom serializer and deserializer. Fine. Similar way, let's define the value. So define value serializer. Okay, so again currently we are using string, but in upcoming videos we will cover our custom serializer and deserializer. That's the minimal configuration you need to add for Kafka Stream. That's it. Now what is our next step? We need to define a Kafka Stream application who will read the events from this transaction topic. Then we need to write a processor who will filter out all the transaction if it exceed 10,000. Then third step, we need to write it to another topic. Okay, so let's create this Kafka Stream application. So to create this Kafka Stream application, what you can do, let me create another package. Let's say stream. Then I'll create a Java class. Then I'll name it fraud detection stream. Simply nothing to do. The very simple step you need to define here. Annotate @configuration. Then you need to enable Kafka Streams. Okay. Since I have added Lombok, I will just add the SL4J for logging purpose. Okay. Now what is the next step? Here I need to create a bean. Inside that bean, I will tell to that bean by defining couple of Kafka Stream DSL logic. Read the topic. Then what is the next? Process or filter. Then write to the destination. This is the three things I need to define to my Kafka Stream bean. So let me create a bean public who will return me the Kafka Stream. Since we are using string serializer and deserializer, let's use the string for now. Key and value as a string. Then define a method called fraud detect stream. Next, we need to pass the stream builder object here so that we can create the Kafka Stream object. Fine. Now what is the first step? read message from the input topic. Now you have the builder. What you can do, tell to the builder, hey, this is my input topic. What is that? Transactions. You read from this topic. What you need to read? You need to read Kafka stream of key as a string, value as a string. Define the variable name. I will define transactions stream. Okay. Is this clear? The first step, we are telling to the builder, just read from this particular topic. Now what is the next step? We need to filter out all the transaction if it exceed 10,000 or some threshold you can keep. So you can simply define like this. Okay, the second step, process the stream to detect fraud transaction. Now you already have the transaction stream. Use that transaction stream dot, you do the filter. Okay, as part of filter, what you will find? You will find the key and value. Whatever you will get in the topic, key and value. Then here you need to, what you need to do? You have the value, convert it to the object, or from the string JSON, just get that node and figure out if that transaction object has the value or amount if it is greater than 10,000. So what I will do, to make it more simple, I will define a private method. Okay, so in this particular methods, what I am doing, I am using the object mapper to convert the Kafka message to the object, which is nothing the transaction object, and I am checking if transaction amount greater than 10,000. These things you can configure dynamically, but for testing purpose, I am using the 10,000 limit. So you could also do it 1 lakh. Okay, but for demo, let it 10,000. So if any transaction amount exceed than 10,000, then this will return true, and this will be marked as a suspicious transaction. So you can simply use that is suspicious, give the value which is nothing the Kafka message you are getting, make it small lowercase, then you can simply print that. You can use pick, fine, and again you will have the key and value, then just add some log statement. I am adding this one, log.warning fraud alert, transaction ID is this and value is this. That's it. Okay, this is the step 2. See, whatever we have discussed in theory, I am following the same step as it is. The first step, we read from the source topic, that is transactions. Second step, in the Kafka stream app, we wrote the logic to filter it. Then we will go with the third step to write it back to the another topic or some destination topic. So what you can do, that is very simple. You have this transaction stream, whatever the fraud transaction you found, you can name it. Actually you can name it, better define a variable. Just define fraud transaction stream, then those fraud transaction stream you want to write it to where? Another topic called fraud alerts. Okay, anything you can give. Now I will just return the source stream, I mean the original stream. Did we follow all the 3 steps? Just add a comment. All the 3 steps we write it properly, step by step. Okay, so since I am explaining this for better understanding, we are using different stream variable for each action, right? But if you want to simplify this using Java 8 functional style coding, you can also do that. We'll use this approach, okay, which will easy to understand for beginners. Now what I need to do, I need to define this as a @bin. Now what we are doing here, reading from transactions, doing the filter, then writing it to another topic. So we also need to create this particular topic. Now we have the Java based approach to create the topic. I will copy this and I will write create transaction topic, not, I will change it to create fraud I'll perfectly copy this, change it. All these two topic, I no need to create it manually. I have defined the new topic from Spring Kafka, which will create the topic for me. All good. How simple is this to just process the data at real time? Currently, we are just doing the read and write operation kind of scenario, right? But Kafka Stream has lot many advanced features. It's not meant for only read and write. That we'll discuss slowly. But this is what the approach you can play with Kafka Stream, the basic flow to understand Kafka Stream. All good. Now what I can do, I will also change here. Okay. Let's not send 10 object. I'll send 50 request. Out of 50, we will find couple of transaction object which will exceed greater than 10,000 so that my Kafka stream will filter them, and currently we are logging it. If you understand the flow, we have this fraud alert topic, right? We are also writing to the fraud alert topic here. After that, you can define multiple consumer to read it from the fraud alert topic and do the needful action. Okay, that's we are not going to do. Let's not make the things complex. Let's understand the Kafka stream basic flow. All good. Now what I need to do, I need to start my Zookeeper and Kafka server. Let me start both. All good. Now let me also start my Spring Boot application. Go to the main class, just run it. It will run on port 9191. Okay, so it started. Let me zoom this. Can you see here? See the state transition from rebalancing to running. If you will find any error, the state will change to the error. That is how Kafka Stream internally maintain the state in rocks DB. Now what we need to do, let me clear this. Okay, let me open the Swagger. Now we have these API transactions. Now try it out. What it does, see the flow again. I am repeating again and again because I want you guys to be clear on this Kafka stream flow. This is the first demo. Going forward, we'll go into the complex scenario. Okay, so we'll send event to this particular topic. Then our Kafka stream application comes into the picture. It will read, process, and write. Okay, let's validate that in the log. Now execute the request. It will trigger 50 requests, right? Out of 50, how many are eligible for fraud or suspicious transaction? See here. Let me filter it, right? We have trigger 50 events to the Kafka transaction topic. Out of that, how many? 18. 18's transaction having amount greater than 10,000. See here. All are greater than 10,000. Now rest 40, not 42, 32 is the correct transaction data. Okay. Now to validate that, what I will do, I will just open the offset explorer where you can visualize the events in the topic. Now let me open that. How many topics we have? Transactions and fraud alerts. So in transactions, you will find 50 events. Okay, total 50 events. Now in fraud alerts, if you will run it, you will find total 18. You can count them, but see, it went to different partition. 1, 0, 2. We have created 3 partition. All the event equally distributed to different partition. That is another beauty of Kafka stream. So if you see here, all the transaction what you are seeing here is greater than 10,000. You can set some threshold and you can validate it. Now it's interesting, right? Using Kafka string, by writing just 3 lines, we are able to filter real-time data. I believe you got some context on Kafka stream basic flow. Now you might have a question, hey, why do we need this Kafka stream application? I could simply create a consumer application here like this, and who can simply listen to this Kafka topic, filter out all the transactions who exceed 10,000, then write it to the fraud alert topic. I can write 3-4 line additional code to do it in Kafka consumer, directly in plain Kafka consumer. Why do I need even this Kafka stream? And this is really an excellent question. And this is exactly where most developers get confused initially when comparing the Kafka stream versus plain Kafka consumer producer logic. Okay. At first view, our observation is right. We can do that using Kafka consumer as well. But the real value of Kafka stream comes not from this simple read and write data flow example. It's in how it processes the data, what guarantees it provides, and how much complexity it saves you when building the stateful, scalable, and fault tolerant streaming application. Okay? Alright. Don't stress, just be patient. All your doubts will make sense once we dive deeper into more scenarios. For now, don't overload your little brain. Just focus on understanding how the Kafka stream flow works. Try with different scenario, try with different example. Okay, cool. That's it for the day. In the next video, we'll extend this example and explore more powerful Kafka stream features. Till then, keep coding, keep learning. I'll see you in the next one.